I've made a lot of videos this year, so of course I don't expect you guys to watch every single one, which is why I'm going to summarize all the videos I made from 2023 under 4 minutes, so you guys don't miss out on the content. Let's go. If you run really fast, you can outpace light in a race, which corresponds to a horizon being generated behind you, where information can't reach you. This has the consequence in quantum field theory of external observers measuring a different number of particles in a vacuum compared to an inertial observer, which the external observer sees as radiation. The same thing applies if you have a black hole with an observer hovering above it. Hovering above a black hole requires a non-zero proper acceleration, which means quantum field theory implies you'll see particles. If we take the Hamilton equations and try to find the equation of motion for a random quantity, we can use the multivariable chain rule to get this formula, where we define this as the Poisson bracket. Sheldon doesn't know how to calculate scattering amplitudes, but we can do it by applying the Feynman rules for each part of the electron-muon scattering diagram to get minus 8 pi alpha times some angular terms. We can write pi in base pi as 1, 0, for the same reason 2 in base 2 is 1, 0, and 10 in base 10 is 1, 0. Here's how to solve the Schrodinger equation for an infinite square well, here's how to solve for a free particle, and here's how to calculate exponential values. Different observers may use different creation and annihilation operators, and we can use this transformation to relate them. Here's how to calculate Hawking radiation the way Hawking actually did it. Just take a scalar field that enters a black hole and compare it to the field that leaves the black hole. The black hole adds boundary conditions that affect the structure of the outgoing field. This is a long calculation, so we finish it in this video. Just a summary of second quantization and the effects that arise from it. Turns out things can interact since we're not on COVID anymore, and we can solve the interaction theories iteratively by using what's called a Green's function. Or is it Green function? We apply what we learned about Green's functions to the phi-4 theory, and we can now see why they're called self-interacting theories, since the field at one point in spacetime is coupled to the field at a different point in spacetime. College Board sucks. I'm running out of ideas for YouTube videos. Okay, what if I solve the equation of motion for mass on a spring on an incline? But get this, there's friction. This is really not that complicated. You're just calculating scattering amplitudes by assuming that particles are infinitely far away in the past, and no, there aren't free fields anymore. Just kidding, there are free fields since we can use the interaction picture. Using renormalization is like trying to put a jump spell on a hog rider. Let's solve the path integral for a free particle. Now this is really highly advanced math, so you got to know how to complete the square. Small number of springs, big number of springs. We can expand the numerator in the Gelman-Low theorem and use Wick's theorem to calculate the numerator. We can use diagrams to make this visually neat, but some people think that these diagrams represent a real physical process. So then you have to write articles online about how that's wrong, and no, you cannot make a perpetual motion machine out of Feynman diagrams. Turns out people like stick figures more than videos made with screen recording ability on an iPad. Look, I can do cool effects like this, and this. I don't know what's in this video because the background music is way too loud. I can't hear what's in this video either. If you turn the USB drive 360 degrees, it flips around. It's my birthday, so instead of having a party, I'm gonna make a video with the birthday paradox. I'm in college now. Here's a video of what my first week was like. I'm totally going to consistently upload more videos about my life in college, and won't get carried away with other things like ballroom dancing, participating in a reality TV show, or top secret government research. Here's what my cutesy homework from the class I audited looks like. I totally didn't get kicked out from the class from posting university property online without permission. Here's how to build a nuclear bomb. Here's how to build an antimatter bomb. I still don't know what cross-sections are. And that's what all my videos this year have been about. I want to give you guys a big thank you. I never thought this channel would grow this big and help this many people. This channel exists because of you guys, and I genuinely appreciate each and every one of you. Next year, I'll be continuing to make videos, with varying consistency. What are y'all's New Year's resolutions? Mine is to get to 2,000 subscribers. Thanks for watching, and peace out.